None?
I think there's isn't there a horizontal?
Well, you tell me.
Wait.
So let's go step one. Is there a vertical asymptote?
No.
Imaginary.
It's imaginary, right? Okay, so there's no numbers.
Oh, there is a horizontal.
There is no numbers that I can put into that denominator and it equals 0. If I put a negative number in there and I square it, I get a positive number. I multiply it by positive 3, it stays positive. I add 1, it stays positive. Positive number, I square it, it's positive. Multiply it by 3, it stays positive. Add 1, it stays positive. I put 0 in there, I get 0 squared is 0 times 3 is 0 plus 1 is 1. So I never get 0 there. So no vertical asymptotes in any of these, right? Right? Because all three denominators are the same.
Yep.
So no vertical asymptotes whatsoever. So, does the first one have a horizontal asymptote? Yes. What is it? Y equals 0. Now, I can't just say, oops, I put equals. I wanted to put colon right there. Okay. I can't just say 0. Y equals 0 because it's an asymptote. It's a line. I got to say it in the proper form. Okay? With me. Y equals 0.
And that's because the top is smaller than the bottom.
Correct. Bottom is bigger than, yep. So from the 3 we learned yesterday. Okay? Number 2, no vertical asymptote. We talked about that. Is there a horizontal asymptote?
Yes.
What is it? Because it's degree on the top is 2, degree on the bottom is 2. Those are the same. So I take the coefficients. So we have 2 over 3. So y equals 2/3 is my horizontal asymptote. Third one. None. Okay? So those are the only 2 asymptotes on those 3 functions. Okay? All good in the hood? Fantastic. So, tomorrow there's a quiz. You have a note card going already. Step number 1 on your note card was what? Find the domain and vertical asymptotes. Okay, so we find the domain and vertical asymptotes. How do we do that? But how? How do we find the restrictions in the domain which gives us vertical asymptotes? Owen. Shh. Set the denominator equal to 0. Okay? So that's step 1. We set the denominator equal to 0. That gives us the restrictions in our domain, which also then become our vertical asymptotes. Yes. Step 2. Find the horizontal asymptotes. How do I find the horizontal asymptotes? By checking, not the exponent, by checking the degree. Okay, the degree of the top over the degree of the bottom, right? And what are my 3 choices? Top is smaller than bottom. What is it?
0.
Y equals 0. Okay, that's 1.
Top is bigger than bottom.
Top is bigger.
There's no
None. And same. It's lead coefficient over lead coefficient. Y equals. Okay? Alright? I like you today. It's just I wanted other people to participate too. Okay?
The degree is always the highest exponent, right?
The biggest exponent. Correct. Okay? Alright? What's up?
Could you ever have just 3x on the bottom and 2x in half, but the bottom always going to be 3x plus something?
No, you could, but you'd reduce that to 2/3. You know what I mean?
Yeah, but I just
Yep.
didn't know if you could have it.
Nope, you can. Yep. Alright? So, today, we're going to go on to step number 3. Okay? Step 3 is find the y-intercept. Okay? So, in your, or with your extensive mathematical knowledge, how do I find, or first off, what is the y-intercept, or how do I find the y-intercept? One of the 2. I don't care. It's what? It's where x equals 0. Okay? It's where x equals 0. Yes. Okay? So it's also actually I don't want to say intersects. We'll say crosses what? The y-axis, right? Okay? Now, remember, we're dealing with functions, rational functions. So how many y-intercepts can there be? How many? One or none. Okay? Because it's a function, my vertical line test says I can only cross my y-axis once. Okay? So there can only be one or none. Oops, I spelled only wrong. Okay? The none case would be if we have a vertical asymptote at x equals 0. That's the y-axis. So that would be a none case, in which we can have a vertical asymptote at x equals 0. Okay? Fantastic. So, how do I go about finding the y-intercept? I do what? Plug 0 in for x. So what am I really finding? That's what you said too, man, right? Nope, that's inverses. Okay, so what am I finding then? I'm finding not f of x, I'm finding f of 0. Okay. So I plug 0 in for x. Now, let's talk even further. Let's take this to the next level. What's my answer going to be? No. What is the y-intercept? What else? What do we call that? A point, right? The y-intercept is a point. So it has to be in point form. Point form is a number, comma, some number with parentheses around it, right? Okay? What are all of these y-intercepts going to look like? Which one's going to be 0? So which one is that?
X is the first number in the...
So all of them are going to look like 0, comma, some number.
Yeah.
Mua, can you grab the door, please? Thanks, buddy. Those L2 extenders are so loud. Okay? So all of your y-intercepts are going to look like 0, comma, some number. Okay? Good timing. Okay? With me on that. Okay? This is step 3. Step 3 is you're going to find your y-intercept. Okay? So, it should go on your note card as step 3. And then on the back side of your note card would be find f of 0. Okay? Step 3 is you find f of 0, plug in 0 for x. Okay? So what do you think step 4 is going to be then? Find the x-intercepts. Okay? So, what is an x-intercept? What? It's when y is 0 But if I didn't want to say y, because we're dealing with function notation, I would say what? Where f of x is equal to 0, yep. Or it's where what? Where f of x crosses the x-axis. How many can there be? As many as the degree, right? Right? Okay. There can be multiple ones there. Okay? Now, a little side note. I know you guys love logic so much. If I have a fraction, a over b, what is the only situation that will allow that fraction to equal 0? If the 0 is on the top. So if a is equal to 0, right? Okay? That fraction can only equal 0 if a is equal to 0. Okay? So if I have a rational function, which is a function that's got a fraction in it, right? Where's the only spots that that rational function is going to equal 0? If 0 is in the numerator. So if I want to find the x-intercept, I'm going to find where my numerator the top of my fraction is equal to 0. That's going to give me my x-intercepts. I set the numerator of my fraction equal to 0, and I solve it. That gives me my intercepts. Okay? Now, next level. What are all of the x-intercepts going to look like?
Some number, comma 0.
Some number, comma 0. Okay. So, front side of your note card should now have 4 steps on it. Step 1, find the domain and any vertical asymptotes. Step 2, find the horizontal asymptotes. Step 3, find the y-intercept. Step 4, find the x-intercepts. Back side of your note card should have, for step 1, it's wherever the denominator is equal to 0. For step 2, top bigger than bottom, none. Bottom bigger than top, y equals 0. Same over same, y equals a over b. Step 3, it should have find f of 0, and then give it in the point 0, comma some number. Step 4 should have numerator equals 0, and then the form of the answer is number equals 0, or number comma 0 is my x-intercept. Okay? So that should all be on your note card. Okay? In preparation for tomorrow. Now, what we're going to do is now we are going to graph. Okay? So, to graph these functions now, we're not going to graph them with a graphing calculator, because graphing calculators are for, the lazy. We're not lazy. Okay? Right? We're going to use our steps. Okay? So, here's problem. F of x equals 2x over x plus 1. Step number 1 says that I am going to do what? Find the domain. Okay, so the domain of this function is all real numbers,
Then x cannot equal negative 1.
and x cannot equal negative 1. Everybody agree with me on the domain for that one? Okay, that means what? That I have a vertical asymptote at x equals negative 1. Okay, so I put that on my graph. One thing I forgot to mention on Tuesday, for the rest of this unit, so for the rest of this calendar year, you should probably bring some form of a straight edge with you to class. Okay? Because you're going to be drawing asymptotes like it's going out of style. Okay? You're going to be working your asymptote off, drawing asymptotes. Okay? Alright? Okay? So that's step number 1. Done. Okay? Step number 2. What was step number 2? Find the horizontal asymptote. So what is the degree of the top? No. 1 is the degree of the top. What is the degree of the bottom? 1. Those two are the same, correct? So that tells me then that my horizontal asymptote is y equals 2. Because it's 2 over 1. Okay? And I put that on my graph. Why would you? I just told you have to bring a straight edge.
Yeah, but
So, if I just told you to bring a straight edge, do you think I want lines that are all curvy and ugly?
Yep.
No. Okay, with me so far.
Yeah.
Okay. Step number 3 was what? No.
No, I was answering questions.
Oh, okay. Step number 3 was what? Find the y-intercept. How do I find the y-intercept? I find f of 0, right? So 2 times 0 over 0 plus 1. That's going to be 0 divided by 1, which is 0. So my y-intercept is what? 0, comma 0. Hey, did you go into French class and start speaking German? Exactly.
I don't take it for an English.
All right. What's my next step? Find my x-intercept. So what do I do there? How do I find my x-intercept? No. Set the numerator equal to 0. Okay? So my numerator here was 2x. I set that equal to 0, and I solve that. And I get x equals 0. So my x-intercept is also 0, comma 0. Okay? The origin is the only point on the graph that is both an x-intercept and a y-intercept. Okay? With me so far? Okay? Now, how are we going to finish off this graph? Okay? Well, we're actually going to do step number 7. Okay? What, Wesley? I did skip 5 and 6.
Is that the ending behavior?
Nope. Nope. So what do you think step number 7 is going to be? Plot some more points. Okay? You're going to plot some more points. So you're going to make a T-chart for every zone. Now for me, I consider zones divided up by vertical asymptotes. So there's a zone here, and there's a zone here. My goal is to get at least 3 points in each zone. Okay? Now currently, on the right zone, I already have a point at the origin. So I've already got one over there, so I only need 2 more. Okay? So let's deal with that side first. I would pick 1 as the next point to try. Okay? If I put 1 in for x into my function, I get 2 over 2, which is 1. So my function goes through those 2 points. Do you see kind of how that function is going to be curving? Okay? Because remember, it can't cross this vertical asymptote. So my function is probably going to start up here at positive infinity and come down, make this curve through here, okay, and then end up down there.
Wait, where did you input 1? Just so I
Into
can-
my original function.
Both up and both numeric
Yep.
down?
Yep, I found f of 1 basically. Okay? So just to verify that, let's try 10. If I try 10, because that's the farthest reaches of my graph, hopefully I'm close to 2, but I'm less than it. Okay? So 2 times 10 is 20. 10 plus 1 is 11. 20 divided by 11 is, I think it's 1.81-ish. Okay? So that is where I want to be.
How you didn't like that one? How you didn't like that one?
Very hard to graph 20 over 11. So it ends up doing exactly what we predicted. Okay? With me? Now I go to the other side. The other side, I'm going to try -2, -3, and -10. I always want to try close to the vertical asymptote because that's more than likely where most of my nice numbers, my nice outcomes will be. Okay? If I put -2 into that function, I get -4 on top over -1 on the bottom, and that's 4. 1, 2, 3, and 4. So I go through that point right there. If I put -3 into that function, I get -6 over -2, which is +3. So I get that right there. So that's kind of telling me which way my line is, or my curve is curving, right? Okay, so it's probably going to start up here, come down, go through those 2 points, and then end up over there, is what I'm guessing. So hopefully when I put in -10, I'm a little bit more than 2. Okay, so I get -20 on top over -9, which ends up being 2.2 repeated. Okay? So it did work out for us. That came through here, went up, and then went that way. Now, here's the cool thing. So we graphed our function, right? Okay? We can get our end behavior, we can get our asymptotal behavior right off this graph. What this is saying that as x goes to -infinity, my function is going to 2 from above. Agree with that statement? Because 2 is my horizontal asymptote. And it's coming from above. So will that be this one over here? So this is saying as x approaches positive infinity, f of x is going to 2 from below. That's hard to see. Let's change that. Switch it back to blue, eh? There we go. There you go. Okay? What this is saying is as x is approaching -1 from the left, f of x is approaching positive infinity. This is saying as x is approaching -1 from the right, f of x is approaching negative infinity.
Will you ever have them when the bus going?
Yep. Yep.
Yep.
Yep. Okay? With me? Okay. So tomorrow on the quiz, what do you think it's going to be easier to do for you on the end behavior, asymptotal behavior problems? Do the graph first, because then you can get it easy. Okay? With me? Okay? If we were to check this like yesterday, we could have put in some huge number here. Well, some huge number here would be 2 times some huge number. That's going to be a positive huge number over a huge number, so that's going to be a little bit smaller. So that's going to be 2, but it's going to be a little bit smaller than 2, so it's going to come to 2 from below. Okay? If I would put in -1.1, I would get negative infinity. Okay?
I'm just still a little confused on like how you know like where to put each like ending result.
Like these blue words,
Yeah, like the top, like the first one is like negative infinity is on the left. How like I don't know.
because we're going. This is negative infinity is way to the left on the graph.
Was it going up? You're going to?
No, I'm going to as x goes to negative infinity. So that means I'm going to the left. These two right here, this one
So just to
and this one are end behaviors.
Okay. So the left and to the right.
Okay. Oops.
So and behaviors go to the left and right, and other behaviors go up. No.
That's ugly.
I got what you're saying. Okay.
7.
Okay. With me? All right. Graph it. So step number 1 was find the domain. The domain is all real numbers, but x cannot equal plus or minus 1. Right? Because if I take the square root of 1, it's really plus or minus 1. Because I'm solving. Okay? That tells me then that I have a vertical asymptote at x equals 1 and a vertical asymptote at x equals -1. So let's put those on there. Okay. Step number 2, horizontal. Degree on the top is 2. Degree on the bottom is also 2. Those are the same. So that tells me that my horizontal asymptote is y equals -2. It's -2 over +1, which is -2. Yes? Step 3 says I need to find f of 0. F of 0 is going to be -2 times 0 squared all over 0 squared minus 1. That's going to be 0 over -1, which is 0. So my y-intercept is the origin. Yes. But watch what I have to do though. Alright? So my fourth step is set the numerator. The numerator was negative 2x squared. I have to set that equal to 0. So when I solve that, I get x squared equals 0. Does that recognize any bells for anybody? That means that 0 here is a... No, it's not imaginary. 0, 0. But because it was squared, it's a double root. Yep, because it's plus or minus. Okay? So in this case, it's a double root here. So that means then that my x-intercept, excuse me, is also 0, 0, but it's a double root. And remember that double roots kiss the x-axis and go away. So they would come in, if this is the x-axis, a double root would come in, it would kiss the x-axis, and it would go away. Okay? That's what a double root does. So at 0, it's going to be a double root. So I just need to figure out if it's going up or if it's going down. Can I cross a horizontal asymptote?
No.
Wrong.
You can?
I can cross a horizontal asymptote.
Just not vertical.
Okay? I cannot cross a vertical. I can cross a horizontal asymptote, just not at the infinities.
Oh, so only in the middle.
Okay? So somewhere in the middle I could. So I could have an upside down skinny parabola in there if I wanted to. Okay? So let's check it here. Let's do 1/2. Okay? If I put 1/2 back into my equation, I get 1/2 times 1/2, which is 1/4, that's the x squared part, times negative 2 is going to be a negative 1/2. That's going to be divided by 1/2, negative 1/2 squared is 1/4, so that's going to be negative 3/4 on the bottom. 1/2 divided by negative 3/4 is a positive number, right? I don't even care what it is. What even is it? 2/3? No, yes, 2/3. Positive 2/3. Okay? Either way, it's above the x-axis, correct? Okay? So this function here in the middle is going to look like that. Now I just got to figure out what it's doing on the other sides. So let's go negative 2 and negative 3. Negative 2 squared is going to be positive 4 times negative 2 is negative 8. Negative 2 squared is positive 4 minus 1 is positive 3. So that's going to be negative 8/3, which is negative 2 and 2/3. Negative 3 squared is 9 times negative 2 is negative 18. Negative 3 squared is 9 minus 1 is 8. That's going to be 2.25. Negative 2.25. Do you see the curve already?
Yes.
Yeah, see the curve? So the curve starts up here, goes through that one, and then curves down at the vertical asymptote. With me?
You know it's a double
Double zero?
because
Because it's
solve it. We had
when we had to square root it. You never know. Okay, let's go over here. If I put in positive 2, I'm going to get negative 8/3. If I put in positive 3, I'm going to get negative 18/8. Because I'm squaring everything, both sides are going to end up being the same. So this one is going to look like that.
So how many numbers do you suggest we do in the text?
At least 3 in every zone, unless it's a little skinny zone like that middle one. Okay? Handle? Go for it. Alright, so domain.
All the numbers in X and then here.
So then that means my vertical asymptote is x equals 3/5. Okay. Degree on the top is 1. Degree on the bottom is 1. Those are the same. So that tells me that my horizontal asymptote is y equals 2/5.
You can write your out if you don't put y in X shape.
I'll give you 3 guesses as to the answer to that particular question, and the first 2 don't count. Okay? Second one, or third one now is find f of 0. That's going to be 2 times 0 over 5 times 0 minus 3. So that's going to be 0 over negative 3, which is 0. So my y-intercept is at the origin, which means the x-intercept, step 4, 2x equals 0. So then x equals 0. So my x-intercept is also there. Is the x-intercept a double root?
No.
No, because I didn't have to square. What?
Will the x-intercept always be 0?
No.
I don't think though. Is anything
Oh. Oh. You just watch.
But
Okay?
I'm not
Hey,
right.
but no.
Oh, if it's 2x plus 1.
There you go. Okay? Alright? So, I got 1 on this side already, so then let's go with negative 1 and negative 10. If I put negative 1 in there, I get negative 2 over negative 8, which is positive 1/4. So I'm up a little bit. So my curve then should be, so if I put negative 10, that would be negative 20 over negative 53. Okay, so that's going to be close, but not quite 2/5. So I'm going to come in along here and make that sharp curve. Okay. Then now I've got to do this side. So let's go with 1. If I put 1 in there, I get 2 over 2, which is 1. If I do 2, I've got 4 over 7. And if I do 10, I get 20 over 49. Excuse me, 47. So that one comes in from here and then makes a sharp turn, almost a right angled turn is what it makes, and like that. Okay? I gave you a goldenrod homework packet today That homework packet is due Friday, December 9th. Not tomorrow, next week, Friday.
Can we do it all?
Okay?
Could we do it on the night and
No.
tomorrow, or
Can't.
just call for me?
You haven't gotten everything yet.
What could we do?
Alright, you can do some of it, yes. You can find end behaviors and asymptotal behaviors and all that fun stuff with it too.
The test tomorrow is going to be all this.
It would look a problem like this with end behavior and asymptotal behavior.